All right, so we're going to look at limits as x approaches infinity and negative infinity. So you can't actually reach infinity, but what they're talking about is the end behavior, what the y values are looking like. So I have two different things that we're supposed to do on example 7. I have the limit as x approaches positive infinity for my function. So if I'm looking at the graph, this is the left side. It comes down and goes over. As I go off, as x goes to infinity, so infinity would be really big numbers off this way, the y values are going to approach this asymptote. And assuming that these are just numbered singly by units, then your y value would be approaching 3. Never actually reaching 3, but getting so infinitesimally close to 3 that it might as well be 3. Then if it says the limit as x approaches negative infinity, you have to look at the other end. So on the other end, it's going up forever and ever and ever. And so that would be, if the x is approaching negative infinity, which would be this way, then my y is approaching infinity this way. It's not stopping, it's going on. And so you can have infinity for an answer sometimes. Depends on if something's leveling off or if it's going up or down forever. But in general, you're just looking at the ends on the left and right side of the graph. So on example 8, we're assuming that these are just units. 1, 2, 3, 4, 5, 6. I think I meant to write those in. As we go off to positive infinity this way, so positive infinity is going off forever this way, the y values are approaching what number?
6.
Good job, 6. And then as I go off to negative infinity, which basically just means the left side of the graph, it is getting closer and closer and closer to 2.
Wow!
So this is one that has weird asymptotes that keeps it between 2 and 6. They never actually reach 2 or 6, but they get really close. Now, sometimes you don't have a graph and we still have to evaluate things at infinity. I'm going to show you 3 methods. And the first one is using just a table and putting in some big numbers. So if I'm looking at the limit as x approaches negative infinity for 1 over x, so the negative infinity would be the left-hand side. If I just did negative 1, I'd get negative 1. Then I'd have negative 1/10, negative 100th, negative 1,000th. If I'm putting in these numbers for x, okay. So to see what we're getting as we approach negative infinity, we're getting bigger and bigger numbers we're substituting in. You could put in negative 1 million, negative 10 trillion. What seems to be happening to these numbers as you go further and further left?
They get smaller.
They get smaller. And actually, just thinking about this, I love fractions, but maybe seeing the decimal representation.
Wait, so do you want us to change them to decimals or leave them?
You can just watch. It's up to you. Those are your notes.
Whoa. It should have went 001, then 0001.
Well, this was 0.1.
I confused myself. It's all going to be okay, but it calmed
Okay,
me
there we
down.
go. 0.1, negative 0.0. So this is getting closer and closer to 0 for x.
I said he.
Okay? And then if we want to see what's happening as I approach infinity this way, I probably wouldn't really mess around with 1 and 10, but it makes for just to see. Okay, we go 1, and then 1 over 10 is 0.1, 0.001. I'm sorry, 0.01. I got excited and put too many zeros. 0.001. So going this way, it also appears that 1 over x as I approach positive infinity, which would be out this direction, also approaches 0. That doesn't mean that they are necessarily look the same everywhere else, just on the ends. And then if I square x, these numbers are going to get even smaller. The 1 doesn't really matter that much. I would just get, well, I would get positive 1. And then I would get 0.01 here and 0.0001 here. It's just going to go to 0 a little bit faster as I go out to the negative infinity. So it's still going to be 0.
Oh my god.
And then these are going to go to 0 even faster.
You guys are messing with my
Let me make sure I'm getting enough zeros in here. All right. So doing a table is one example, but there are other ways. So on the back of this page, we're going to talk about 3 choices and one general thing that we can just know. Okay? So we're going to 0. The idea is we're putting in bigger and bigger numbers because infinity, you're getting bigger and bigger numbers. Okay. So limits at infinity of 1 over x to any power. For any positive real number n, if you take the limit as x approaches infinity of 1 over x to the n power, your answer is 0. And negative infinity, 1 over x to any power, is 0. This is a rule you can memorize, and if it shows up, you can just go, hey, I know that that is 0. Because the bigger you make the power down here, the smaller the numbers you're going to get, the faster it's going to get close to 0. All right, so the 3 methods for finding limits at infinity is to use a table, which we'll look at. You can use a graph, and you can use algebra. So we're going to take and look at all of those. So this says, find the following limit using all 3 methods. So here's my function, and we're going to put these numbers in first using the table. And if you... I'm just going to do this. So I'm going to have to put 1 in. 5 times 1 squared minus 7 times 1 plus 1 divided by 2 times 1 squared plus 1 plus 5. Shh. And we get negative 0.125. If I'm smart, I can do a second and enter, and it will give me what I just typed, and I can replace all the 1s with 10s by using the insert function. I can make this 1, 0. And then I can go over here to where there's 1 and say insert and make that 1, 0. And then the other one just becomes plus. And then if I come over here and put in 10...
Love, the land's about to smack you.
Okay, plus 5. So if we do this, we get I don't know if that's right. I can't